Hi everyone, Dankman here. Today, Monday, May 4, it is, if you're watching this video. It's my pleasure to introduce our new and final topic for the year, which will cover actually two different quote-unquote units. This topic comes from this concern, quadratic functions. And today I'm just going to introduce that concept. Okay, let's review how a function works. So let's take, for instance, f of x is equal to 2x plus 5. Okay? The input plugs into the function, and the function does its process, beep, boop, 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 and generates an output. Okay? The input will be the x variable. X gets plugged into the function, beep, boop, 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 and what comes out is the output f of x. Okay? In a table, that would look like this. We have x. We do our calculations to generate, beep, boop, 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 our output, f of x. So, for instance, if I were to plug 0 into this function, I would input 0 by replacing the variable x with the number 0. I get 2 times 0 is 0. 0 plus 5 gives me 5. And so I get the input-output pair 0, 5. Or if I were to plug in the number 1 for the variable x, it would become 2 times 1 plus 5 equals 2 plus 5. So plugging in 1 gives out 7, so input 1 matches with output 7. Or I could go in the negative direction, which would give me 2 times negative 1 plus 5, and that gives me negative 2 plus 5 for 3, so input of negative 1 gives me output of 3. Okay? And we recognize this equation. This is a linear function because its equation has the m slope and the b y-intercept, shown clearly because of how it's written. And so we could graph that equation easily, and we can also tell from the table what the graph of this function should look like. So if I drop down an x-axis and a y-axis, I get these 3 points. Negative 1, comma 3, which is shown right here. Negative 1, 3, 0, 5, shown here, and 1, 7, shown there. So, yes, my graph is pretty awful. I'll clean it up for you. Apologies. And when we plot those 3 points, negative 1, 3, 0, 5, and 1, 7, they all line up in a nice clean line. That nice clean line has the y-intercept of 5, and it's got the slope of over 1 up to a slope of 2. Now, we know a lot about this function because it's a linear function, and we studied linear functions so thoroughly, and it's in slope-intercept form. But not all functions create the same kind of shape when we graph them. And so what we're introducing today is a set of functions that behave way differently than lines. This line, for instance, starts by increasing and will increase forever. Anywhere you look on this line, wherever it is, it will always be increasing. So a little zoomed out view of the line I just drew. This is maybe really zoomed out view of this line. It's always increasing, everywhere. But we're going to look at other functions now. So just to show you briefly, I could have functions that look like this when I graph them. I could have functions that look like this when I graph them. I could have functions that look like this when I graph them. I could have functions that look like this when I graph them. Okay? And you remember some of these shapes from some of our earlier work in last semester. But we're going to introduce more formally now this shape. and the function that goes with it. So, when we looked at linear functions, they had a particular type of equation that matched with them. I'm now going to introduce this brand new equation. This function's equation says f of x equals x squared. That's x to the second power. To get a feel for how this function works, I'll go ahead and set up this table. Okay, x squared is of course x times x, so x to the second power. So this exponent, this second power, is something that none of our linear functions happened to include. Okay, and so when we graphed those linear functions, they looked a certain way. Now I'm interested to see what happens when I graph this function. So if I try to plug in, for instance, the value 0, then in the calculation I'll do 0 squared, 0 to the second power is 0 times 0, and that gives me 0. So I get the ordered pair 0, 0. I could plug in 1, in which case I get 1 squared, which is 1 times 1. That gives me 1. So that looks interesting. You plug in 0, you get out 0. You plug in 1, you get out 1. But if you plug in 2, you get 2 times 2, and that's 4. And if you plug in 3, you get 3 times 3, which is 9. Okay? And maybe going into the negatives a little bit, if I input -1, I carefully square -1, which is -1 times -1, which gives me +1. So -1 input gives me +1 output. -2 input, -2 to the second power, gives me -2 times -2, output +4. And if I input -3, the same thing happens. I do a negative squared, so I get a negative times a negative, which gives me a positive, which we've been paying attention to since the beginning of the year. So I get all of these points. Some of my inputs are positive, some of my inputs are negative, one of my input is neither positive nor negative, but all of my outputs are positive, and they have this nice mirroring pattern. You'll notice 9, 4, 1 in the top, 9, 4, 1 in the bottom. Okay? You might ask yourself, what's the slope of this line? And you might say, okay, if my change in x is +1, +1, +1 every time, because that's what I was doing, +1 every time. My change in y, well, from 9 to 4 is down 5, so that's -5. From 4 to 1 is -3. From 1 to 0 is -1. And then I start going up now. So I'm increasing, so the quote, the slope, the change in my function has started to get positive. And it goes +1, then +3, then +5. So my slope, so to speak, of this function doesn't seem to stay the same. It's not the same number, and it's not increasing or decreasing the entire time, but changes. So here's this new function. This is the most basic quadratic function, okay? And what makes a quadratic function quadratic, you'll notice that word quad, is that it's got a square in it. And by square, I mean it's got a second power. So the input gets raised to the second power. And that's what's uniquely quadratic about this function. And I'm going to go ahead and graph. And I know my graphing skills are not very pretty, but I'm going to go ahead and graph these points, 7 points that I've collected, okay? -3, 9. So I'll go ahead and plot that point. And that's 1, 2, 3, and up to 9. So here's -3, 9. Okay? This point here, -3, 9, shown here. -2, 4. Okay? -1, +1, 0, 0, 1, 1, 2, 4, and 3, 9. Okay? So you can see 3, 9 here. This is 2, 4 down here. 1, 1 down here. I've plotted them all. And I want to try and fill in the gaps here, and we talk more later about that. just to get a sense of what the shape of this curve is. And this is the curve I get. It doesn't seem to have a straight lines. It's curvy. And it doesn't stay increasing or decreasing. It switches. Okay? It's got this really interesting lowest point on it, which we discussed all the way in our Introduction to Functions unit. That lowest point is called a minimum. Okay? For positive input values, it's increasing. For negative input values, it's decreasing. Okay? And this shape has a name. This graph, the graph of a quadratic function, is called a parabola. And this is the beginning of our introduction to this new topic, quadratic functions, and they involve multiplying the input value times itself. And so the first exercises we're going to begin this unit with are going to be exercises in which we multiply input values together. I'll go ahead and release example videos of that along with your assignments for the day.